Generous philanthropic contributions from viewers like you. Thank you for supporting TVO's journalism.
If gene editing could make humans better, should it? I'm Nam Kiwanuka. Tonight, renowned author Walter Isaacson on the breakthrough that made that idea more than just science fiction. Scientific breakthroughs that change the course of human history aren't always recognized at the time they're made or during the lifetime of those that make them. And that might have been the case for what's known as CRISPR, if not for a pandemic and the race for a vaccine to stop it. And if not for the riveting new book by acclaimed biographer Walter Isaacson. The book is The Codebreaker, Jennifer Doudna, Gene Editing and the Future of the Human Race. Walter Isaacson is professor of American History and Values at Tulane University, and he joins us from New Orleans, Louisiana. Hi, so nice to see you again.
It's good to be back with you. Thanks for having me.
I was going to say, should I say New Orleans, Louisiana?
Everybody here pronounces it differently, too. Don't worry. Just come visit.
Well, you've been on the agenda before, and you've written really engrossing biographies on Steve Jobs, Leonardo da Vinci, Albert Einstein, Ben Franklin. And this is the first time you have featured a biography on a woman. And some might say she's not a household name. Who is Jennifer Doudna?
She's the person who, along with Emmanuel Charpentier, won the Nobel Prize this past year because they invented a way to edit human genes called CRISPR. That's a system bacteria have been using for 1 billion years, but Jennifer Doudna and her team were able to repurpose it, recode it, so that it would cut our DNA wherever we targeted it. And so that's going to help transform us in our fight with genetic diseases. It's helping us already in our fight against COVID, and eventually it'll allow us to design traits we might want in our children, which is something that could be very good, but also a little bit scary.
Very controversial. We'll talk about that in a few moments. Doudna worked on CRISPR with a team of researchers and shared credit and her 2020 Nobel Prize, as you mentioned, with another scientist, Emmanuel Charpentier. So why write about her and not Emmanuel?
Well, Jennifer Doudna has had a longer career, and what she has done in her life is at the very beginning, when she was a graduate student, she helped figure out the structures of RNA. And that helped her and her advisor understand why RNA was probably the cause of the beginning of life on this planet. And then by using RNA structures, she helps decode some of the issues with CRISPR. And then she meets Emmanuel Charpentier, and they're able to turn it into a gene editing tool. After that, Jennifer becomes very involved, more so than Emmanuel, who is a more private person, in leading the global discussion over the ethics of CRISPR. And so I think, and also leading the fight against coronavirus. So I think when you see the sweep of Jennifer Doudna's career, it's almost as if she's a great narrative thread, a person who I can walk hand in hand with and bring the reader along with in this journey of discovery that begins early on with her reading Jim Watson's book about the double helix of DNA, and then figuring out how she's going to do the same things with RNA. But Emmanuel, as you say, is a really important character in the book, and she's certainly the best supporting actress in the book.
Well, in the acknowledgments, I think you describe her as being charmant. It's interesting, Doudners, how she got here in part because her father pushed her, and a lot of people dismissed her. As a young girl, she couldn't be a scientist. And in the book, you write that women in science tend to be shy about promoting themselves, and that has serious costs. I was curious, what did you mean by that?
Well, I think that if you do some of the studies of scientific papers, it's a fact that's been shown that women are usually a little bit more modest. They don't use words like this breakthrough discovery or, they don't use the dramatic words, and they sometimes don't get cited as often. I think Jennifer Doudna And Emmanuel Charpentier may have turned that around because their paper describing how CRISPR can be a gene editing tool may be the most cited paper around these days. But when Jennifer was growing up, she was told by her school guidance counselor, no, girls don't do science. And when in the 1990s, most of the male scientists who were biologists and geneticists were pursuing the Human Genome Project, looking at DNA, trying to map our DNA. And some of the women who were not part of that, including Jillian Banfield, Emmanuel Charpentier, they focus on RNA, which is the less known molecule. But as it turns out, RNA is far more useful to us these days. It's at the heart of the vaccines we've created to fight COVID, and it's the guide in this tool that we've used called CRISPR to edit our genes. So I think in some ways, being a bit of an outsider helped Jennifer. She wasn't like the other boys running on the soccer pitch to where the ball is. She was going and playing a position that she knew would pay off later.
Well, you mentioned RNA. I just wanted to read an excerpt from your book about that. You write, having a map of DNA did not, it turned out, lead to most of the grand medical breakthroughs that had been predicted. More than 4,000 disease-causing DNA mutations were found, but no cure sprang forth for even the most simple of single-gene disorders, such as Tay-Sachs, sickle cell, or Huntington's. The men who had sequenced DNA taught us how to read the code of life, but the more important step would be learning how to write that code. And that key to writing that code, you explain, is RNA. You describe RNA as the unknown sibling of DNA. What does RNA do in relation to DNA?
DNA sits in the nucleus of our cell, and it curates our genetic information. But like a lot of famous siblings, it kind of just sits there curating the information. It doesn't go out and do much real work. What RNA does is two different things, major things it does. First of all, it does the real work of building proteins. It goes into the nucleus of our cell, gets some of the genetic information from DNA there, and that's like a blueprint. It goes to the manufacturing region of our cell and starts making proteins, whether it be hair follicles or fingernails or neurons or enzymes or hormones, whatever protein we need. And that's called messenger RNA because it takes the messenger, it acts as a messenger from the genetic code in our nucleus to make products. That's exactly how these vaccines work from Moderna and Pfizer, which is we program that messenger RNA to build a bit of the spike protein that's on the coronavirus, and that gives us an immunity to it. Another thing that RNA does is it can act as a guide for enzymes. Enzymes can be scissors. They're scissors that can cut DNA. And what happens in a CRISPR system is RNA is coded and said, we tell it, find this spot of DNA, find this sequence, and then cut it. And so that's what guide RNA does in the CRISPR system.
You explain things so well. You couldn't be a professor by any chance. I'm just joking. Well, with that being said, I really like how you describe our key scientific discoveries of the 20th century from the 30,000-foot level, so to speak. You say over a century ago, the three fundamental kernels of our existence were discovered: the atom, the bit, and the gene. Can you tell us more about that?
Yeah, the atom and the bit and the gene are these fundamental kernels. And around 1900 or so, we pretty much got an idea about all of them. And the first half of the 20th century is building on the notion of the atom with Einstein's theories and others. We get to things like atomic power, nuclear bombs, and GPS and space travel. And it's really a half century of physics. The second half of the 20th century is really dominated by the bit, meaning a binary digit. And we can encode all information in zeros and ones in these bits. And that's what the digital revolution was about. The microchip, the internet, the computer, all combining to creating a great revolution. Well, the third basic particle is the gene. And as I said, in the year 2000, we pretty much sequenced the DNA in human bodies and mapped where most of our genes are in those sequences. And now with CRISPR, we can rewrite that code of life. So I think the first half of the 21st century is going to be a revolution in life sciences that will be even more consequential than the revolution we saw in digital technology in the second half of the 20th century.
Now, when people hear that we can rewrite, I think it brings up a lot of other questions, other ethical questions to consider. And with the CRISPR tool, since we can now edit our genes, I wanted to read another passage from your book, The Codebreaker. In November 2018, a young Chinese scientist who had been to some of Doudners' gene editing conferences used CRISPR to edit embryos and remove a gene that produces a receptor for HIV, the virus that causes AIDS. It led to the birth of twin girls, the world's first designer babies. There was an immediate outburst of awe and then shock. This is where the story gets even more interesting. First of all, can you tell us a little bit about the Chinese scientist, Dr. Who? He had a relationship with Jennifer, no?
He went to some of Jennifer's seminars on CRISPR, and he went to Rice University, but he's from China. And this is a selfie he took with him and Jennifer. They weren't particular friends, but what Dr. He Zhongqi did was he crossed an ethical line that Jennifer Doudna and the other scientists had agreed we shouldn't cross. In other words, he used CRISPR in an early stage embryos or reproductive cells so that the edits he made would not just affect one patient, but they would be inheritable.
Why is that a line not to cross?
Because it means that all of the children and all of the descendants would have this edit. And so you're not just editing a patient who gave consent, you're editing the entire human species. Now, you've asked a good question, especially after he did it to edit out a receptor for a virus. After this pandemic, you might say, explain to me again, why shouldn't we cross that line? Why should we not edit the human species in order to make us less susceptible to viruses? But I think most scientists and ethicists would say, let's start with what we know is safe, which is doing it in an individual patient who gives consent. And maybe there'll be a problem, but it's not something that'll be inherited by all the descendants. I think we'll get to the point in a decade or so when other people are making inheritable edits like this Chinese doctor did. But at the time, it was like he was violating one of the rules of the road, which is let's start with edits that are in a patient that gives consent rather than making inheritable edits.
He actually thought he was helping, right?
Oh yeah, he thought he'd be a hero. And for about a day he was. Front pages of the papers, there was kind of this awe at what he had done. It was like first person to do a test tube baby or cloning Dolly the sheep. But I think that once people thought about it, they realized it wasn't medically necessary what he did, and it wasn't all that safe. We hadn't studied this enough. So I think it'll be a while before we make inheritable edits, but already we're doing incredibly important things, such as editing a patient down in Mississippi so that she no longer suffers sickle cell disease, doing it for blood disorders, doing it to fight cancer at the University of Pennsylvania, doing it up in Portland to fight congenital blindness. So these are miracle things that are happening with gene editing.
When this happened, what was Dr. Doudner's reaction to it?
She got an email that said baby's born, and she jumped on an airplane and flew to Hong Kong, where an international summit on the ethics of gene editing was about to take place. And the Chinese doctor was supposed to be there. So she gets and she lands and she meets with the Chinese doctor, convinces him that he has to explain all the science at this conference, but then also tells him that she's shocked that he would do that without going through proper authorization.
Has she changed her views since then?
I think her views have evolved, and so have mine, on gene editing in general, and probably on inherited or heritable gene editing. I think that before the pandemic and before we've seen how important and useful this tool could be, we were cautious. It seemed like we were, playing with fire or playing God if we were editing our genes. But every day she started getting people coming up to her and saying, I want to show you a picture of one of my children who has a genetic disease. And I promise you, I could show you right now on my phone, I get 8 or 9 every morning. I wake up and there are these emails that say, here's a picture of my granddaughter. She has this rare genetic disease. They say she's going to die in 3 years. Or here's a picture of my son, and here he is swimming, but his muscles are deteriorating. They say he's not going to make it. And they say, can you get me in touch with Jennifer Doudna? Can you use CRISPR to save my baby? And I think that helped all of us focus on how do we use this for good, as opposed to worrying about what 10, 20 years from now might happen if we start using this unwisely.
I think when we do talk about some of the questions that have arisen from this, and it must be for Dr. Doudner to think that this is coming from her invention. You write in the book that enemies of certain countries can use the technology to for on the other side, but also it can create a world of immense inequality. I think the pandemic has exposed how unequal our societies are. How does that fit into the conversation? What do we as a society need to consider?
I think the most important thing is the one you raised, which is at some point we're going to be able to design some of the genes of our children. We're going to make sure our children don't inherit Tay-Sachs or Huntington's or sickle cell. We'll even be able to do things, at some point, like help affect the muscle mass or height or eye color or hair color or even skin color of children. And I think when we do that, and as we go further down this road, which are things we don't understand quite yet, such as how to increase memory or something, we have to make sure that the rich don't just buy better genes for their children. If this is all free, this is all sort of a free market thing at a genetic supermarket, people who are wealthy might buy enhanced children. And that we already have inequality, as you just said. But this would kick it up into a higher orbit, the inequality, and not only make it higher, but would encode it in our human species. And so I think, you've read Brave New World. You've probably seen the movie Gattaca. We don't want to have a species that splits into a genetically enhanced elite and then people who are genetically unenhanced.
Well, in the book, you do also talk to people who have certain illnesses, and you ask them if they did have the opportunity, would they change so they don't have those illnesses anymore? What did they think of this technology?
There's a wonderful young man in the book named David Sanchez, one of the great philosophers in my book, but he's only 17 and he loves to play basketball, except for when he doubles over in pain in the middle of the court because he gets an attack of sickle cell. And they tell him, at some point we may be able to edit your genes and in such a way that your children won't inherit sickle cell. It's just a single letter mutation in the 3 billion pairs of letters we have. So it can be done sometime soon. And he says, that would be great. And then a little while later he says, but maybe it should be up to the kid when the kid is born. And you say, why? And he says, well, because I learned a lot from sickle cell. It helped forge my character. It taught me how to get up off the floor, to be persistent. It even taught me empathy for other people. And I thought, wow, that's pretty deep that a kid would say that. And then a little bit later, I asked him, and he said, I've thought about it again. I think if I had the choice, I'd make sure my children did not have sickle cell. I said, well, what about empathy? He said, well, I'd love to teach them empathy, but I don't want them to go through pain, to suffer. And the reason that's an interesting story to me is it says we're all going to have first thoughts and second thoughts and third thoughts about this, and there are no easy answers. But we have to consider sometimes when you edit something out of the human species, you edit the diversity out of the species. But on the other hand, we do want to make sure children aren't born with sickle cell. And so I wanted to use real life examples like David so that the reader, instead of me saying, here are the answers, because there's no answers at the end of the book, but they can say, go hand in hand with me and Jennifer and David Sanchez and all these others and think through what are your first thoughts, your second thoughts, your third thoughts about when we should use this.
This is one of the reasons why I really love this book, is that it forces you to reconsider your first thought and not be so judgmental on other people. And again, that's the crux of all the work that you do. It's all about curiosity and trying to find answers.
No, they're great ethicists thinking about this issue. And Jennifer has gathered people from around the world. But I think that we shouldn't just leave it to scientists or politicians. We ought to have our first, second, and third thoughts. There are a lot of good books. There's a woman at Dalhousie University up in Canada, Francois Baylis, has written a book called Altered Inheritance, which really dives deeply as a philosopher and bioethicist into these issues. So I hope people will read my book and see what a journey of adventure it is to get to this amazing technology, but then they'll study the biology more and they'll study the bioethics more.
So, well, let's go to the very beginning of the book. It's this year has felt like 10 years, but you start the beginning. You start the book on March 13th, 2020, and it's the day that we all realized that the pandemic was in North America. While the rest of us likely didn't know how to react, Jennifer Doudna, she snapped into action, both as a mother and a scientist. What happened to her that day?
She had brought her son, Andy, to a robots building competition in Fresno, California. And at about 2 or 3 a.m., she wakes up because she's worried about the spread of the pandemic on the Berkeley campus. They're just starting to close it. And she wakes up her husband and says, we got to get in the car and go pick up Andy. I don't want him in the convention center with 1,000 other kids and teachers. And so they get in the car, they find an all-night gas station, and Andy's an only child. So when they pick him up, he's like rolling his eyes. But as they leave the parking lot, they get a text message saying, robot competition canceled, all students go home. And she realized at that moment that she and others would have to turn their attention to fighting the coronavirus. And she had been doing gene editing tools, detection tools. She had started a company to use CRISPR to detect viruses. And so she gathers 50 other scientists from the Bay Area, and she starts working on, let's make home detection kits for viruses. Let's make ways we can have testing labs around the country to test for coronavirus. Let's figure out ways we can use it, use CRISPR the way bacteria use it, just to kill viruses rather than just do vaccines. And maybe even let's think about ways we can edit ourselves to be less receptive to viruses. Her rivals, who she has fought against in the race to understand CRISPR, who are at MIT and Harvard, they're doing the same thing. And the good thing is this time, instead of being rivals, they're sharing a lot of the information and not asserting patent rights. And so I think it reminded them of all the things we're write about in this book. It's now hit home because of coronavirus. Now we have to understand, how do molecules work? And that's what made it not only more timely, but more immediate. It hits home now.
It was like a perfect storm, because in the book you do write about the competition amongst the different groups. And then when this year happened, 2020 happened, they all came together and collaborated even more. And I'm sure a lot of people are watching this and listening to this. It's very serendipitous for you because, you know, you have this amazing scientist, this incredible technology, and then a global crisis where we need RNA technology. Were you already working on the book before? Like, how did that all come together?
Oh, I've been working on the book for 7 or 8 years, gathering string, and then I was writing the book when coronavirus hit. And I, of course, said, well, let's delay the book because this is all part of the story. And I knew before coronavirus hit that we were going to use RNA as a messenger to help make vaccines, and we're going to use it as a detection technology. But no, I had no idea how timely, how immediate, and how pressing this would be, or how interested people would be getting in how our bodies work.
You participated in a vaccine study and didn't know whether or not you were getting the placebo. And you also got a chance to experiment with CRISPR. Can you tell us about that?
Well, first of all, I wanted to learn how to do it. And so I went into Jennifer Doudna's lab. And within 2 days, with the help of 2 graduate students, I was editing human genes using CRISPR, a human kidney gene, and put a little phosphorescent recorder molecule in it so that it could glow under certain conditions. Now, don't worry, we flushed it down the drain with a lot of chlorine, so it's not part of the But it was just, I love the beauty and sometimes the simplicity of science. And likewise, I believe in citizen science. I don't believe we should just say this is some priesthood of scientists out there that we can never understand. And my way of doing that, too, was to join the Pfizer trial. I just signed up at a local hospital here to be part of a clinical trial, which everybody should do. All sorts of clinical trials are going on now. And even though I got the placebo, this was back last July, I signed up. So that after 6 months, they switched me over. So early on, I got the real Pfizer vaccine. And I did it because, A, to be useful, to be a citizen involved in science, but also because it uses messenger RNA, the thing we've been talking about. And to me, that's a really interesting molecule. And one way to learn more about it was to have it be working in my own cells.
And knowing what you know, we only have about 30 seconds left, but knowing this technology, the way that you know it, are you hopeful for where we might be in a year from now?
We've turned the corner against viruses in what has been a million-year struggle, maybe, because viruses keep mutating and we're always trying to play catch-up. But with an RNA vaccine, you can recode it every time it mutates, every time we get a new virus. And I think this will be a game changer, and it'll turn the tide in the fight between humans and viruses.
Mr. Isaacson, thank you so much again for being on the show. It's always a pleasure learning from you. And I said before we taped how organized you must be because there's so many incredible characters in this book. Thank you for always reminding us to stay curious.
Thank you so much.
And that's it for tonight's Agenda in the Summer. I'm Nam Kiwanuka. Thank you for watching TVO and for joining us online at tvo.org. And we'll see you again next time.
The Agenda in the Summer with Nam Kiwanuka is made possible through generous philanthropic contributions from viewers like you. Thank you for supporting TVO's journalism. In 2015, a migrant boat sank off the Libyan coast. It's up to a team of dedicated professionals to uncover their identities.
Intonsa questa aspettativa, no? È proprio pura.
And give them back their names.
Per quella giustizia che si deve ai morti. Ripeto, onorare i morti e servire i vivi.
Number 387, tonight at 9 on TVO. Take 6 craftspeople.
If you remove that, oh dear God.
Turn back the clock.
I'm a cabinet maker who's been drawn back 150 years.
And renovate this house with Victorian-era skills.
My grandma has a sewing machine like this.
We're putting the blood and sweat into arts and crafts.
You know, it's nice to work with your hands in a way that you haven't done before, but it's bloody hard work.
The Victorian House of Arts and Crafts continues Thursday at 9 on TVO.
We have a certain relationship with the trees.
The forest provides food. The forest provides medicine.
It's like a miracle for the planet.
That's something that we need to be thinking about when we start talking about how we as humans interact with the forest.
Trees are the boreal, you just have to respect them just because they survive.
We have a problem right now because of human-caused climate change.
We have the ability to make whatever it is that we imagine, so let's just start imagining a new path.
Borealis, a TVO original, next Tuesday at 8:30.